Please welcome your host for this afternoon, Joachim Ladra.
Ladies and gentlemen, Hannover Messe 2026, welcome to one of the key events of this show. Welcome to NextGen starts now. We have a crowded house today, and I'm awfully happy to see so many faces from all the different aspects that make up the hydrogen ecosystem. We are celebrating this event today with members from the hydrogen application space, from the hydrogen technology space, from the hydrogen infrastructure space, from the hydrogen distribution space, from the hydrogen supply chain, all the different elements. We're welcoming guests from our existing customers, from our potential customers, from our strategic supply chain partners, and from our two owner companies, Daimler Truck and the Volvo Group. At cellcentric, we're awfully happy that at last we have reached a point in time where we can launch our new baby to the public, our NextGen system. A special welcome goes to Mr. Stefan Ruhenhoff, Parliamentary Secretary at the German Federal Ministry for Economic Affairs and Energy, who will join us today from the side of the political domain. Ladies and gentlemen, the first day of 2026 Hannover Messe is almost over, and with this event we're about to add one additional element in the technical tour de force that is Hannover Messe 2026. My name is Joachim Ladra. I'm head of sales, marketing and communication at cellcentric, and I'm very much looking forward to guide you through the next 90 minutes as the moderator of today's event. At cellcentric, we are very proud in our legacy. We are building on over 3 decades of expertise and knowledge in the automotive fuel cell space. As a joint venture of Daimler Truck and the Volvo Group, we have an excellent understanding of what the heavy-duty business is all about. And it's those two elements that we combine in the next milestone of fuel cell technology, our state-of-the-art NextGen system. Today, we are celebrating out of a team of over 560 employees at the cellcentric sites in Germany and Canada, all of them passionate and all of them driven to drive fuel cell technology forward to take this technology to the next level. And this is what we're going to jointly do today. The NextGen system not only unlocks a new level of fuel cell performance, ladies and gentlemen, it also covers the needs of a very broad range of different applications. While it is primarily designed for the use in heavy-duty long-haul trucks, it can cover the needs of many different use cases that are, with other technologies, very hard to decarbonize. Think about coaches and buses. Think about stationary power generation. Think about rail. And think about the entire off-highway segment, heavy-duty mining trucks and the like. NextGen is a milestone in the decarbonization for all of these applications. Because as you will learn over the next 90 minutes, NextGen and its technology and performance is basically driven by 2 key considerations: fitness for purpose and total cost of ownership. Because all the different applications that you see on the screen behind me are investment goods. They need to fulfill a mission and they need to earn money for their operators. That is the fact of today's world in carbon and fossil fuels, and that will still be the same logic tomorrow once we start decarbonizing these applications with fuel cells and hydrogen. Now, ladies and gentlemen, we have a lot in store for you, and I would strongly suggest let's dive right in. We have technology, we have infrastructure, we have the voice of the customer, we are looking into our supply chain, so there is a lot at stake. And therefore, ladies and gentlemen, without any further ado, please welcome to the stage for his welcome speech, Mr. Nicholas Lochlan, Chief Technology Officer and Management Board Spokesperson of cellcentric.
Wow, a lot of people here today. And I'm really, really happy to see so many of you from all walks of life, as they say, when we talk about the hydrogen infrastructure and hydrogen ecosystem space. It's a real team effort. We'll talk about team a lot today, not only team cellcentric, but team hydrogen. And of course, this hall here in Hall 11 is testimony to this specifically. Joachim just said that today is a real milestone, and we will present you today a real game changer that's still under this blanket over there. And why that is the case, we're going to explain a bit now. And I'm going to utilize the most favorite picture I have when I want to explain what decarbonization in the heavy-duty landscape actually means. It's not an AI-generated picture. It's how, especially if you drive around Germany right now, probably exactly at this point in time, the resting stations look like today. They're fully covered with heavy-duty trucks. And I can confidently say everything that you see in this hall today, everything you wear, everything that is tangible in here, has seen the inside of a truck. Now, why is that important? Heavy-duty trucking on road and distribution of goods will continue to grow also in the future. It's the core and the backbone of our society. And why is that the case? Because we live in an economy where we share jobs. We specialize in jobs. Ours is heavy-duty fuel cells. Yours is, of course, something else. But most of it in our economy is transported on the road in a heavy-duty truck. Now, to decarbonize this is the most difficult to decarbonize automotive segment there is. Why is that the case? These trucks are on the road all the time. They drive constantly, nearly every day. And whenever they're down, that's not a good thing. So this is actually the exception. They're supposed to be on the road and running. And of course, they're investment goods, and that means TCO matters. You're a professional in the heavy-duty space. It's a business-to-business relationship. Everybody is trying to make a business case, and our job is to provide a second basis to that when we talk about the future of heavy-duty drivetrains. In many aspects, that means that we help, together with the colleagues that you see in the picture, help economy going, help life going. And that led us to, and not only us, but our shareholders, to the foundation of our company. At the end of the day, our job is to power a sustainable life. We want to keep economy going, continue to grow it, but sustainably. Our technology can provide the basis to do that in those trucks that you see. Now, cellcentric was formed in 2021 by two of the big truck manufacturers that we have in Europe and globally, the Daimler Truck AG and the Volvo Group. And they, of course, have one common vision: to decarbonize the last slide that you just saw. And there are several aspects to it. There's no one silver bullet, but hydrogen and fuel cells specifically in long haul are key to doing that. So our mission is clear. We have to provide a solution for one of the hardest, but also one of the most essential jobs there is. And our setup is perfect to do that, of course. Whenever you talk about how to run and operate a truck and how to design it, of course, then you need to know how to start from scratch, from the beginning. You need to know the end customer's purpose. And nobody is better to do that than real truck OEMs, of course. And that's what sets us apart from other fuel cell system manufacturers. We have access to and know how to specify, how to design, how to run, operate, and test and validate a product that is really at the core of each and everybody's business in the logistic chain. You can already see the one that you see on the screen here at our booth, and the one that will replace it, you will see soon. Now, our ability to work together with successful and big truck OEMs makes us, in a specific situation, possible to actually design each and every aspect of our fuel cell system to the end customer's use case. And that means that from the design of the system architecture all the way to the choice of how we use and try and build the cell deep within the system and how we run the system, of course, we can make to the best benefit of everybody. And we do it uncompromising. designed to that most difficult heavy-duty job there is. BZA 150 is already deployed today. It's doing a good job at custom applications. You've read about it maybe in the news and also online, and how customers today, and some of you are here today and can testify to it. We'll speak with some of them later, I hope, and how successful that technology already runs today and how reliably it does the job. Those vehicles with our fuel cell systems inside can go over 1,000 kilometers even today on the road. And it's a testimony of the capability of our fuel cell systems and the trucks that operate them, of course. So we are already today, and tomorrow even more so, the home of heavy-duty fuel cell systems. Now, when we talk fuel cell systems, of course, we have one thing in mind, and that's TCO. Our customers make specific decisions when they are engaged with making a buying choice and which product they use to do their core operations. And it's total cost of ownership, TCO. Now, what does that mean for us at cellcentric? We've codified it a bit so that our team understands what to focus on, specifically when we talk about designing and producing heavy-duty fuel cell systems. One, cost effectiveness. Of course, in the B2B segment, there is no room for thrills and nice and fancy stuff. Every euro we invest in the system needs to be there for our customers to earn money, nothing else, because that's what we need to take care of. Two, efficiency, especially in the heavy-duty space, but most importantly in the long-haul application. Fuel consumption is key. It was in diesel, and it will be tomorrow also with hydrogen-driven drivetrains. And that's why fuel cell systems with their benchmark efficiency are so key for the long-haul heavy-duty application space. NextGen will provide a completely different level already today and especially tomorrow. Durability and reliability are an entry ticket when we talk about heavy duty. If your systems and your end product is not durable and is not reliable, you don't even have to start. Our customers are unwilling to compromise on that, and rightly so. So everything we do is basically specified, tested, validated according to what you require from your diesel engines today. Nothing else will do the job. And of course, being an alternative and new technology, we're together with our customers looking to provide additional customer benefits with the technology we have, and we'll talk about a few of those later. In all dimensions that you see here, we want to lead the way. We want to be the benchmark. One thing that's good is that the application of fuel cell systems, especially the heavy-duty spot, is nothing that's been around for a long time. Now, as Joachim already mentioned, we've been in the fuel cell space for 3 decades, and some will say, okay, there's already something out there. But heavy-duty fuel cell systems are a different animal to passenger car fuel cell systems. You design it for a different purpose, for a different use case, so your technology solution will end up at a different outcome at the end of the day also. The good thing is that within the application of our technology, we've learned a lot in the deployment of our existing product already, and based on our heavy-duty tailored advanced engineering, we've come up with items that we've incorporated into our NextGen that completely outperform our already existing fuel cell system, although it's already doing a good job. And that's also the reason why we've decided to completely replace it. This will be the system that scales. We're really excited about what's going to happen next. I've talked about teamwork. Now, why is teamwork so important? Because in the hydrogen space, and I'm sure many of your business conversations that you've had today talked about this, our job is not done within our area of responsibility. Our job is an ecosystem job, and it requires teamwork across the entire hydrogen value chain, all the way from hydrogen production to the end customer use case, and every chain in between. Only if we synchronize together can we do something that, especially in Europe, we've not done so well in the past. And that is utilize our technology leadership that we have today, especially in hydrogen, and actually scale it. Europe's problem never was really innovation. Europe's problem was always scaling innovation. And that's where we are continuously reaching out, and many of you are here in the room today. If we were working together to organize the entire hydrogen ecosystem value chain and scale it together. Now, why is that important? Because today, we are technology leading in this technology. And we're going to dive into it a bit more, and we're going to show you why that is the case when you benchmark it to others. It's a real testament of our leadership. Policymakers today, especially in Germany in the recent past, have been really supportive now. And I can actually say that we're feeling a bit of momentum right now within Europe, but Germany specifically. I think more and more people have come to recognize that our technology, hydrogen technology per se, is not only something worth fighting for, but something that can contain and produce value-creating jobs for the future. And that's something in new technology we have not been very successful of, as you guys know. Here, we start from a position of strength, and that I'm looking forward to having some input later on how we continue to do this and secure it for Europe. Because then, with that teamwork, we can all be successful and have actually something where we all can earn money in the scaling of our technologies. Ladies and gentlemen, I'm really looking forward to making this historic journey together with you. Our contribution to making this happen is NextGen, and we're going to take a look at this now together. So thank you very much, and enjoy the rest of the program so far.
Ladies and gentlemen, as we've heard from Nico, fuel cell technology is not only about decarbonizing heavy-duty applications. Fuel cell technology is also leveraging Europe's strengths in manufacturing and automotive engineering. Nico spoke about teamwork. Nico spoke about an ecosystem. For those of you who know me, you know I like to talk about a puzzle. A puzzle where many different contributors provide a single piece. A puzzle that we still need to bring together. Because in the end, what counts is a comprehensive, holistic picture in hydrogen once we have all these pieces together. Many of them are already on the table, and today we're going to add one more. And in bringing these puzzle pieces together, we're also very happy from the cellcentric angle that we're getting an increasing amount of headwind from the political domain in making that challenge happen. In that sense, we're very happy to welcome today Mr. Stefan Ruenhoff, Parliamentary State Secretary at the German Federal Ministry for Economic Affairs and Energy. Mr. Ruenhoff, the stage is yours.
Thank you. So, Mr. Laughlin, I have to say, thank you. Thank you for your passion you have shown today. And thank you for the endurance as well, because what you are doing is real work, it's heavy work, and it shows us how innovative we can be here in Germany. So, distinguished representatives of the state of Baden-Württemberg, ladies and gentlemen, excellencies, experts in the field of hydrogen, in the field of transport, thank you very much for the opportunity to speak here today, and congratulations, I really have to say that. Congratulations to cellcentric on the development of the next generation fuel cell. I just said how much work it is, how much knowledge you have to put in, and I have to say decarbonization of transport is one of the central challenges on the road to climate neutrality by 2045. And what we have to say is an efficient and cost-effective fuel cell can make a truly significant contribution. The achievements of cellcentric alongside other examples here at the Hannover Messe show that Germany remains at the forefront of technology in many fields, and German companies continue to invest in developing forward-looking new technologies, high-tech, and bring them to the market. and German engineers remain leaders when it comes to patent filings and product innovation. And we have, of course, and it was mentioned already, we are not in a very easy situation now, but in every crisis, there's also an opportunity to make steps forward. And maybe we are today in such a crisis where we might make new steps forward. And I can definitely say that the federal government actively supports these developments you are doing through a variety of funding programs. In the case of fuel cells, for example, through the Energy Research Program of the Federal Ministry for Economic Affairs and Energy, so our ministry. We also ensure government support for research, and we support the next generation of skilled professionals. And the success of fuel cells does not depend solely on cutting-edge research in individual technologies. It is equally important to build the infrastructure and expand the use of the technology across the transport sector. And here the federal government is making a decisive contribution through its interministerial hydrogen and fuel cell technology innovation program. This program is investing over 1 billion euro in the transport sector alone and supports investment in vehicles and hydrogen refueling stations, as well as research and development. We cannot consider hydrogen use in transport in isolation, I have to say. Hydrogen must be produced, must be transported, stored, and where necessary also processed, and that all at competitive prices. And there we have a way to go. We can do it, something on that. We can contribute to cost reductions. I'll come back to it in a second. And for fuel cells to be a viable alternative, we need a full hydrogen ecosystem that is itself competitive, with a functioning market, reliable infrastructure, and diversified production and import routes. This means we need to support the ramp up of hydrogen production in a pragmatic way. We also need to simplify overly complex regulation, and we are currently working on a range of measures to achieve that. This includes improving the legal framework, building efficient demand-oriented infrastructure, and lowering the production costs. And one example is the hydrogen core network that is pre-financed through an intertemporal mechanism by the German government. And it also involves developing low-cost imports and ensuring demand through market-stimulating instruments such as the greenhouse gas reduction quotas and, for example, the lead markets for hydrogen-based products. And let me say one thing. We are here at the Hannover Fair, Hannover Messe, with Brazil as a partner country. I do believe that there are huge potential also working closer together with Brazil, especially in the field of hydrogen. And I do believe that there are other countries in the world, and we all know that, and we are already on the way to work with those countries to build in new import routes in order to address these issues. But I also have to say, and I mentioned it already, we have to do more on our regulation. And why do I say that? Because when I look at the European level, I see the RFMBO delegated act. And we all know what costs this regulation actually creates. And there, it is another example, I unfortunately have to say example, where we can work, where we have to work on, where we have to make progress in order to lower the costs for hydrogen and for hydrogen production. And I have to... I want to be honest. It's not an easy way to go, but it is a way to go which makes sense. We need to go that way. We have to put more emphasis on it. And your example, and you are one of a lot of examples we do see in the industry. And I do see here a lot of people who are very interested. Why are you so interested? Because here more knowledge does exist, more approaches do exist for industrial solutions. And I do believe that these examples show that we take and that we need to take the chance, but we also have to take the challenges of building a viable hydrogen economy seriously, but we are not intimidated by them. Innovations such as those from cellcentric shows that Germany remains able to compete internationally when it comes to new technologies. And I can promise we want to go that way. We need to address those regulations who create costs, and we need to get your knowledge in order to make more progress and in order to be successful in this field. And I want to thank you all for your attention and looking forward for further discussions. Thank you.
Ladies and gentlemen, at cellcentric, we pride ourselves in continuously pushing the boundaries of fuel cell technology. And we are very happy that we are not alone in this quest. Therefore, next, we will hear from two companies who are totally committed on the decarbonization of the heavy-duty trucking world. We will hear from two companies that have made great strides in pushing the fuel cell technology and the hydrogen ecosystem forwards, and who keep doing so. We will hear from two companies who have significantly invested in the technology, in cellcentric, in NextGen. Next, we will hear from two of the biggest truck manufacturers in the world. We will hear from Karin Radström, CEO of Daimler Truck, and we will hear from Martin Lundstedt, CEO of the Volvo Group. Now, unfortunately, both Karin and Martin could not make it to us here in person today, but they definitely did not want to miss the opportunity to speak to us today on the occasion of NextGen Starts Now. Therefore, we have a little video message prepared for you. Roll the movie.
Warm greetings to all of you in Hannover. Welcome to one of the world's largest and most important industrial trade fairs.
A special greeting also to our friends at cellcentric hosting you on site. Unfortunately, Karin and I, we cannot be with you in person today, but we are happy to join you virtually. Both of our companies, Daimler Truck and Volvo Group, share a clear and strong commitment to decarbonize the commercial vehicles industry.
Yep. And our ambition is nothing less than to decarbonize our entire product portfolios. And we already do it with a dozen of zero-emission truck and bus models in series production from both companies. So I think our whole industry is showing great progress. But there is no silver bullet for decarbonization. Two key technologies will lead the way: battery electric and hydrogen. Because one thing is clear, we know that Europe will need hydrogen in many different industries, so there will be a hydrogen economy, and therefore it's only logical to use hydrogen also to power commercial vehicles. We believe hydrogen is critical for Europe's future and for Europe's economy.
Absolutely, Karin, and it's essential for Europe's resilience. Hydrogen and fuel cell technology are vital elements for the commercial vehicle industry. We know there is still much to be done across the value chain, from hydrogen production, distribution and transport to the build-up of hydrogen refueling infrastructure across Europe. This takes a great deal of collaboration and joint effort. We hope our friends in the energy sector will also step up now to help ensure the transition accelerates in the coming years. And one of our most important contributions is our joint commitment to and investment in cellcentric. Cellcentric has a clear and dedicated focus on heavy-duty fuel cell technology. And already today, cellcentric's current product, the BZA 150 fuel cell system, demonstrates strong performance and reliability.
Indeed. We already use it across a broad range of products and applications. And maybe to give you one example, in our Mercedes-Benz Gen H2 trucks, we have had really impressive performance. In 2023, we did our hydrogen record run with 1,047 kilometers on one single filling of liquid hydrogen. And we also have trucks in customer trials already since 2024, with an average consumption between 5.6 and 8 kilograms, depending on the gross vehicle weight, which is between 16 and 34 tons. So already good steps taken, but today our focus is on the NextGen, which is the next major milestone, and we are really proud of the entire cellcentric team. Because building on the success of the BZA 150, the NextGen represents a new level of fuel cell performance.
Yes, Karin, and the NextGen is a true game changer for fuel cells in the heavy-duty segment. And we can say this with confidence. We know NextGen quite well already, and you can almost see it behind us here. And a clear priority for NextGen is total cost of ownership, obviously, and to optimize the total cost of ownership, because this is what truly matters in heavy-duty applications. And today marks the first public presentation of NextGen, and we are both happy and proud to share it with all of you in Hannover. So NextGen is not exclusive to the Volvo Group and to Daimler Truck, Karin.
No, I mean, we've deliberately set cellcentric up as a tier 1 supplier, so we invite other customers to integrate NextGen into their products. The technology is suitable for a wide range of heavy-duty applications on highway and beyond. And NextGen makes a key contribution to the decarbonization of many different applications. So for now, enjoy the reveal of the NextGen and take a deeper look into cellcentric's technology. Thank you.
Thank you, Karin. And Karin and I, we invite you to join us on our journey towards a hydrogen economy and ecosystem for competitiveness, but also for coming generations. Today's launch of NextGen marks another milestone on that journey. And the cellcentric team has much more in store for you throughout today's event. So please take advantage of the opportunity to connect with the cellcentric team on site. So from Karin and myself, farewell. Take care.
Thank you very much, Karin and Martin. Now, ladies and gentlemen, we've covered a pretty broad range of topics already. We've heard about truck stops, we've heard about teamwork, we've heard about technology, we've heard about 3 decades of expertise in automotive-grade fuel cell systems. We've heard about different applications, different requirements, total cost of ownership, and fitness for purpose. All jolly nice, but that's not what you came for. What you came for is NextGen. And I think now we've reached the point in time where there's been enough suspension building. Let's proceed to what you've all been waiting for, because now it's time to say NextGen starts now.
To move the world, you need power. Uncompromising power. Welcome to cellcentric, the home of advanced heavy-duty fuel cell systems. We've come a long way. Raised by 2 strong parents, we made heavy-duty our sole duty and keep showing what is possible. Now, as a Tier 1 supplier, we aim to scale up. Our next generation will define the future of decarbonized heavy-duty applications. One product, multiple possibilities. Let's shape the future. We're ready to empower your product with performance comparable to diesel. Available for new partners. NextGen starts now. BZA 375.
Yeah, ladies and gentlemen, and here it is. I read about that some people really get emotionally engaged with machines. I'm pretty close to doing that also, I think. BZA 375, that's the next generation of heavy-duty fuel cells, and it is truly going to define the standard in heavy-duty fuel cell system industry. Now, we've called this a game changer, and let me explain a bit why that is the case from our perspective. It's completely designed to your heavy-duty tasks, and everybody that knows a bit about the commercial industry can see it when you already look at it. It's a single system. It fits into a heavy-duty 13-liter diesel engine compartment the way you're used to it. It has substantial amount of power in it, 375 kilowatt, so it's designed to do every heavy-duty application task you today expect from your heavy-duty diesel engines today. We have a weight less than 500 kilograms, so payload is actually also going to be addressed, because at the core of heavy-duty long-haul, the payload and the freight that you forward is key, and we need to make sure you're capable of doing that, so no restrictions compared to a diesel. The biggest difference we see today is that this system will enable you to have on the truck, compared to our already really, really competitive BZA 150 twin system installation, 20% less fuel consumption than today. 20%. In my former life, I used to run diesel engine projects, and if you would come up with a figure like that, you would have been thrown out of the room, because that's completely crazy, right? And it just shows you the chart that I had earlier with the innovation that is ahead of us. The amount of benefit this will have on the TCO calculations that you're all experienced today is huge, nothing short of that. And that means, especially in long haul, where range and flexibility is key, with this system in the truck, you should be enabled to have a vehicle that has less than 6 kilogram per 100 kilometers in a European standard heavy-duty long-haul application. That is the game changer. And not only that, when we talk about fuel cells and you engage with people who are interested in the industry, they usually come also with, challenge you on the product and the product characteristics. And one of them they always challenge you with is, but cooling. Yeah, cooling. Always regarded as one of the Achilles heels when taking a fuel cell system into an automotive application, especially on the heavy-duty side. Why? Because compared to combustion engines, we struggle a bit to get rid of that waste heat. So today, a lot of trucks that you see that have fuel cell systems installed have huge cooling packages, also even installed behind the cab. Now with this is going to change. We've designed the product so that at its max waste heat capability compared to BZA 150, we have been able to reduce 40% of that waste heat. Why is that substantial? Because with that, it should enable you to use cooling packages on your trucks that are comparable to diesel cooling packages today. And that's, of course, a big, big customer benefit. We talked about that last C in my Cedric chart. That is exactly, we listened, we understood what the pain points are, and we've consequently addressed them. Big cost saving on the vehicle, big efficiency increase on the vehicle, all for the end customer, for TCO. All that, of course, is possible because we have substantially increased our power density, 40% increase to our current generation. And at the end of the day, of course, this fuel cell system, and you already see it by looking at it, is designed, validated, and tested to the heavy-duty specifications you're aware of today. 1.2 million kilometers translated into 25,000 hours of lifetime. And of course, reliability that has no compromises compared to your diesel engines today in store. Ladies and gentlemen, this should and will change the way we think about fuel cell systems in transport, the way we think about fuel cell systems in heavy-duty trucks. It addresses the core topics that customers need to worry about when they are faced with the choice of powertrains tomorrow. And with this, we're leveraging our unique setup. Let me talk about teamwork again. Not only is cellcentric set up to have a comprehensive in-house value chain, and that is true on the engineering side, but also true on the production side. We deliberately set ourselves up to control everything that we need to control to ensure those product performance characteristics that we just talked about. We are able to design to the catalyst powder all the way down to system architecture performance. Only what we seem feasible and only what we seem necessary to build the game changer. And we'll talk about those aspects later. But they're not only our in-house contribution. There's more contribution, of course. We'll talk about our great setup that we have with the supply base that we have, our supply chain partners. And we'll hear some examples later on. Because also here, we want to rely upon and encourage the innovation power of our supply chain partners and their scale effects that they have, utilizing their modules and platforms, all again to do two things: increase firepower and innovation, and therefore the customer benefits that we want to achieve, while at the same time drastically reduce cost. Those two objectives are key to us at cellcentric. Now, talking about collaboration with our partners and shareholders. I guess many of you have read the news recently. Something that in itself hopefully can also be a game changer again is the intended collaboration we have with the Toyota Motor Corporation. The Toyota and Daimler Truck and Volvo intended collaboration in cellcentric will, of course, be something that, again, will hopefully provide us with some more encouraged future optimization going forward. And, of course, with all three being equal shareholders in our company, strategic outlook when we talk about hydrogen society, hydrogen economy. All three companies support that target and believe in it. And we are going to be the manifesto in that. We are going to be the dedicated, heavy-duty fuel cell system center of competence. And hopefully this is already going to be the game changer and the platform to do this from. The intention is to further strengthen us as the leading manufacturer in heavy-duty fuel cells. Why is that important on the heavy-duty side? Our heavy-duty system is, of course, not only, as mentioned, tailored toward heavy-duty trucks. It's essential that that segment is addressed because that is where we have the scale effect. But of course, our system today is capable of addressing all the relevant segments that are in the heavy-duty space, similar to diesel engines today. And they will profit from the high volume on the heavy-duty side. Coaches, rail, stationary, and of course, heavy-duty off-road equipment. BZA 375 is set up as a real world engine, as you know it today. Not only capable of fulfilling the other heavy-duty segments, but also globally. All relevant markets have been considered, all standards have been considered. It's ready for a global rollout. Many partners are here today, and you join us today, you're a testimony to that. And you join the cellcentric team today. You can identify them because they wear this great t-shirt. And you can talk business with them today. Now, we've talked about teamwork, and now is also the time where I would like to thank Team Cellcentric. This team has done an outstanding job the last couple of years. I'm extremely proud of them, and only because of their hard work, experience, expertise, and dedication was this possible to happen today. Let's give them a hand, also online, because they're looking from back home. Thank you. You rock my world every day, and hopefully you will rock the Hydrogen Society's world every day too. So that's why, dear guests, we've invited quite a few of our team, and I'm looking forward for you to meet them and talk hydrogen and talk heavy duty and talk fuel cells. But we also have them in the program now next, and they will let you into the ins and outs and the what and the why and the how of BZA 375, the new standard of heavy-duty fuel cells starting today. Thank you very much.
Thank you very much, Nico, for this comprehensive overview about all the different dimensions in which BZA 375 will take us a step forward. Now, looking at you guys, I know we have a rather engineering-heavy audience in front of us today. So it's only natural that you are not only curious about the what, you're also curious about the how. And this is exactly where our dedicated experts now come in that Nico already teased. Now, you will understand that they will not let you into all our secrets, but at least into some of them. That much we owe you today. Therefore, the next step, please welcome here on stage my dear colleague and our head of fuel cell system development, Mr. Joachim Blum.
Thank you for the introduction, Joachim. As we've heard today, ladies and gentlemen, heavy-duty trucking is all about total cost of ownership and fitness for purpose. That led to three main challenges that our customers expected us to solve in the development of the new product here. Number one, make the fuel cell system as efficient as possible. Number two, more net power, higher power density. This product is the proverbial 13-liter, 500 horsepower diesel engine of the future. We want to make the same use cases that fleet operators rely on today possible also in the future with this product. And number three, solve the cooling challenge, which today, as was mentioned, can only be solved by installing additional complex, expensive equipment in the fuel cell truck with severe limitations when we talk about higher ambient temperatures or in grades. How do we do it? One key enabler was moving from the twin system design of combining two smaller fuel cell systems to achieve the job to a single system design. Fewer components, much better use of the available space, and a huge complexity reduction. We cut the number of interfaces between the truck and the fuel cell system in half. I'll jump back to the slides. Look how cleaned up the BZA 375 looks to our previous product. Now, that gave us the opportunity that one single system, to install a maximal amount of fuel cell active area, the power generating heart of the fuel cell system, into the new product. 40% more than previously in the twin system. So we are talking about a much, much bigger stack in this product, meaning more net power and thus higher power density, better efficiency, because now with the same power demand, we're able to run the fuel cell system at a much more efficient operating point. Combine that with the enormous improvements we made in the fuel cell technology in that stack, which we will hear about in an upcoming presentation. So all in all, this product will deliver, as Nico mentioned, up to 20% lower fuel consumption when you run it in a drive cycle. And since fuel efficiency translates directly into less waste heat, if we do an apples-to-apples comparison to the BZA 150, we're talking about a 40% lower waste heat that the truck needs to get rid of when we compare it to the BZA 150. So a single system was the first key enabler. A second key enabler is the integration of an innovative air supply system. The BZA 375 is cellcentric's first product that features a two-stage compressor with a variable nozzle turbine. Why is that good? Well, for efficiency purpose, we raised the operating pressure in the BZA 375 to literally supply more air to the fuel cells to operate more efficiently. The variable nozzle concept allows us to set that pressure in every moment, in every situation in the truck, to a value that is optimal for efficiency. And with the two compression stages, we are able to deliver these higher pressures also at higher altitudes, if needed, at 3,000 meters up to 4,000 meters. There's a second key benefit to raising the pressure, and that is we will be able to maintain humidity levels when we raise the temperature of the fuel cell system to a higher value, also to ease the cooling challenge. And that allows us to lift the standard operating temperature of the fuel cell from 60 to 70 degrees Celsius at the fuel cell inlet, and if needed, up to about 100 degrees at the fuel cell system outlet to make cooling easier. Not only the air supply system is designed to optimally support the operation of the fuel cell stack, but all of our, as we call them, balance of plant components. Let me highlight just a few important ones. The humidifier uses the product water that's produced in the electrochemical reaction in the fuel cell stack to humidify the dry compressed air entering the stack, hydrating the membrane of the fuel cell, maintaining conductivity, and making sure that that stack works as it was designed to, and also avoiding premature degradation. A highly integrated media distribution manifold at the bottom of the fuel cell system. Now that component really is the one that makes compact system integration possible, and it routes hydrogen, air, and coolant to the stack via a bottom interface. We also redesigned the hydrogen supply system, featuring a recirculation blower, an active recirculation blower. Now that component that you see here is about the same size as the blower that we used in the BZA 150 product, but it delivers up to 2.5 times more mass flow than in the previous product. Last but not least, the purpose of the fuel cell system is to deliver electric power to the truck, and that's what that component, the DC-DC power converter on top of the system, does exactly. It delivers the generated power to the truck and provides the voltage level that the truck's electric motor needs. And we will hear more about this component a little later in one of the discussions we're having. Ladies and gentlemen, the BZA 375 is a truly software-defined system. Its improved architecture goes hand in hand with advanced operating strategies who make possible that the fuel cell stack in every situation across a broad spectrum of duty cycles, ambient condition and states of health sees exactly the operating conditions that it needs to function optimally, to continuously optimize durability and efficiency of that system. Ladies and gentlemen, there's much more about this product that I can't possibly talk about today, like its production-oriented design or its excellent serviceability. All in all, we believe this product sets a new benchmark, and maybe a little bit you share my enthusiasm for this product. But in any case, thank you for your attention.
Joachim, thank you so much for the insights in the broad range of levers our engineering team has pulled to get to the performance level of BZA 375. Joachim has in his presentation briefly glanced into the heart and core of the fuel cell system, the fuel cell stack, where the chemical reaction of the hydrogen and the oxygen from the ambient air happens, where the black magic happens that creates the electrical energy in the end that we need out of these fuel cell systems. Now, the fuel cell stack, ladies and gentlemen, proudly has been an in-house component at cellcentric in previous generations, and it remains so with BZA 375. Leveraging our strong in-house expertise in both product development and manufacturing, leveraging many patents and intellectual property on that domain, and leveraging the opportunity to the best possible degree, adjust the stack performance and the system performance that will bring us to the best possible result for the customer in the end. But now, before the sales guy gets too much in the technical topics, let me present you with our second technical expert of today. Please welcome here to the stage cellcentric's Head of R&D for Membrane Electrode Assembly Components, Ms. Natascha Weidler.
Thanks, Joachim. You would be allowed to talk about the Technik. And welcome everybody also from my side. As Joachim has nicely stated, the stack with its hundreds of single cells is what gives our system its heartbeat. It powers it with the electrochemical reaction from hydrogen and oxygen into water. Now, you all have heard the target, 20% less fuel consumption. That's quite a lot. And we also had to rethink our stack product strategy quite a bit. I would like to dive directly now into some highlights of our stack product strategy and start from inside out with our single cell design, which is one of the major contributors for the fuel efficiency, or to decrease the fuel efficiency. So when we heard the target of the less fuel consumption, that translates now into our electrochemical world to our developers into make me an MEA that is super efficient. Make me an MEA that has around 70 to 100 millivolts higher potential compared to BZA 150. And yeah, that's for all of you, and I saw some who also are familiar with electrochemistry, that's not only a performance boost, that's really next level. And I want to say that I'm very proud to say that our development team has mastered it, this challenge. And here behind me, you see now some greetings from our cell development team. They wanted to take you with on a little tour while I'm speaking here into our advanced engineering prototyping space. So here is where the development starts. it's really from the scratch we start ink mixing, some numbers. We made over 600 different ink variations to develop the cathode layer for the 375. That meant also 500 coatings on our table coater that you will see here behind me in one of the snippets. That also meant we hot pressed 500 CCMs, and we tested them in our single cell testing laboratory. So I can say we had to go through many floody designs, and all those design variations were a necessary step in our development, because the interaction between highly innovative powders and inks and ionomers and all those ingredients, what makes the cathode layer, they are quite complex. And in opposite to what an AI agent would tell you when you ask him what our CCM is made of, it's actually not an alloy catalyst. So we make that purely with platinum. And this was a challenge, and I'm very happy that we found the key to make these highly innovative platinum catalysts into our layer design and make them with a very good recipe to what comes out here. One of the big advantages for our company is actually we are not only developing the design, we work hand in hand with our process engineers, and they tune the hell out of the design again with process parameters and translate it to manufacturing and scalability. But enough from the cell design. We pulled some other levers as well. As you have seen from the previous slides, we have increased the stack size. The stack size means as well we have a bigger footprint. And by having a bigger footprint, we have doubled the active area from our overall stack. And this was quite a smart decision, because by doubling the active area and by having this bigger footprint, we are able to operate in a different operation window now at higher potentials. And this means, again, we have higher efficiency. But not only about efficiency and fuel consumption, also cost is one of the things that are very relevant for a product development. And here I can say some nice add-ons that the footprint brought with. That is that we had a better utilization of bipolar plates, and we have, from our cell row design in the stack, we have a 3 identical configuration of cell rows, and that makes the scalability of the production again more cost efficient. Another good point is that we have flipped one of the cell rows, and that allows us to shorten the bus plates. Again, another point where we reduce complexity to have a cost advantage. So now I talked a lot about hardware developments on cellcentric. And one thing that is also worth to mention is that our bipolar plates are still made out of carbon. So we stick to our carbon bipolar plates, because there are the durability aspect is one of the things that we do not want to sacrifice for the higher efficiency. We want to have a higher temperature operation, and that is for us the best fit with our carbon bipolar plates. They also enable, because we have now quite a huge footprint, we also need some design features that allows us a homogeneous depression over the footprint. And also here, bipolar plates made out of carbon are for us the choice and the aim to go for. Higher temperature is one of the key aspects also where we have thought of to somehow reduce the complexity for the coolant requirements. We increased the inlet temperature from around 60, 70, from BZA 150 to 80 degrees. And the outlet temperature, we can run up to 100 degrees. That is quite also, you can think, a stress for the cell. But that is the big advantage of us in cellcentric. For us, development means not we specify a component. It means we specify components, design it together with an operational strategy into a product that is then also processable and scalable. And with this, I want to say thank you for your attention and hand over to Joachim again.
Natascha, thank you so much for outlining verbally and visually with that video how much goes into the development of our stack. And I think it outlines quite well why we put so much emphasis in keeping the stack an in-house component at cellcentric. Now, from a technical point of view, you've seen quite a good range of all the different activities that we do to advance fuel cell systems to the next level in heavy duty. However, at cellcentric, there is only so much we can do on our own. In many areas, we heavily rely on strong strategic partnerships with our partners and friends from the supply chain. And when I say supply chain, to many of you, one name will come to mind. One name that is Markus Siegel, cellcentric's former head of global procurement and after sales. And I say former because as of April 1st, Markus has taken up a new role within cellcentric and is now cellcentric's global head of operations. At the same point in time, we have appointed as his successor Jochen Sang, who in his previous role already was responsible as head of R&D component and software development for the technical angle on this cooperation with our supply chain partners. And it is these two colleagues, Markus Siegel and Jochen Sang, to whom I want to now hand over the stage to shed some light into the fact for us how we collaborate with our strategic partners from the supply chain.
Yeah, Joachim, thank you very much for all the flowers. I saw a lot of faces today where I am being known as a few years. A lot of years working with you together in a quite challenging environment. I guess everybody from us knows that with Corona and all that stuff that came up, we had multi-challenges quite over the last few years. I'm really proud to introduce my successor, Jochen Sang. As Joachim said, he robbed me the complete speech, so it will be much smaller as expected. I'm looking forward to be the head of production and looking really forward to that new challenge together with Kai and the colleagues to build up Esslingen. That will be a challenge, and thank you, Lars, for being also today here, who was the former COO, and Matthias, the complete CXO guides there. So thank you very much. Also, we will introduce today one announcement that we made in, I guess, in the last weeks, months, with a company called like Brusa together, which is sitting in Switzerland. I'm very proud to pull Mr. Fink on the stage, because Jochen Sang will guide you through now. My role will be out of the stage, and these two colleagues will guide you about the next few minutes. Thank you very much.
Yeah, thank you.
Markus, thank you very much for the introduction. Thank you very much for many years contributing to our supply chain and bringing that forward. So thank you. Ladies and gentlemen, I'm looking very much forward to the new responsibilities. A close and trustful collaboration with our strategic partners is key, making cellcentric and the product even more successful in the future. Having been part of the supplier collaborations in the previous engineering role, I'm very much forward to looking or to working in the new role now. So mutual expertise, built a great product, BZA 375, and we are looking at a very promising future with that. I'm totally convinced. So still the future relies on stable supply chains, and we are seeing in recent years and recent months, not only starting with Corona, but we see that there are lots of changes. Companies are exposed to global volatile economy changes, extraordinary and complex structures in the supply chains. So we see that there is geopolitical tension, there is fluctuating prices on raw materials, energy prices fluctuating, being unpredictable, transport disruptions, very important at the moment, influencing our energy prices, and of course climate-related events making rapid change to happen. To remain competitive, organizations need to go beyond optimizing costs only, but they need to embed into their operations resilience, agility, long-term stability, and today I'd like to focus on partnerships because strategic and trust-based partnerships are key. Such partnerships enable a deeper collaboration, they increase transparency, they strengthen in that volatile world the risk management, and they foster innovation. In a world where disruptions can go across the planet in hours, it's really important and key that strategic supplier relationships stabilize our business continuity and our operational excellence. So we rely on strong and trusted partnerships, on partners who not only understand our strategic direction, but help to actively change these and actively shape these and go beyond. Especially in the hydrogen environment, we have additional challenges on top of the general economical headwinds. Overall industry is still characterized by volatile shifts in business opportunities. We have still an immature market, and we are still very early in the industrialization stage. So therefore, I'm pleased to today highlight one of our strategic supply chain partners who exemplifies exactly these qualities. A partner who has consistently demonstrated reliability, technological capability, and shared commitment to a continuous improvement. Today, we would like to introduce you to Brusa High Power, with whom we are strengthening our collaboration to support our long-term supply chain strategy. So, already on stage, welcome together with me, Dr. Fink from Brusa.
Yeah, thank you very much. I'm very happy to be part of this launch event here today. And I would like to start with a short introduction of Brusa. Brusa was founded 1985 in Switzerland, and we are one of the few real pioneers in e-mobility. So we have invented a lot of technologies for EVs. We have also launched a lot of products as first mover to the market. So we can say today in more or less almost every EV is a technology from Brusa inside. When we look at our automotive product portfolio today, We provide all power electronic devices you need to build an EV. Is it a pure battery electric vehicle or a fuel cell electric vehicle? So we have all kinds of DC-DC converters, onboard chargers, and inverters in our portfolio, and this in the power range from kilowatt up to even more than 1 megawatt. What we are doing here for this fuel cell system, we provide to cellcentric what you call this FCI, fuel cell interface, and this interface has several functions integrated. The main function is a DC-DC converter that converts the electrical voltage of the fuel cell stack to the significant higher voltage the rest of the powertrain needs. Additionally, we can connect and disconnect the fuel cell stack from this high voltage network, and we provide monitoring function for this full fuel cell system. And last but not least, we are organizing and controlling the whole power distribution to all these components that are connected to this high voltage network. As we have heard before, efficiency is very important, so also for us, for this product, efficiency is the most important technical KPI. And we perform this electrical energy conversion with an efficiency of around 99.5%. So we have almost no losses in this big guy. And with that, we are also very unique, so we do that better than others are doing that. And with this high efficiency, we are, of course, contributing to this overall high efficiency, very high efficiency of this fuel cell system.
Thank you very much, Dr. Fink. Great introduction into Brusa and into your products. Thank you for especially describing the FCI, what you are providing to us. We are very pleased to have you as a strategic partner, and we have always greatly appreciated working with you. It is and was a collaboration on eye level with mutual respect, a true partnership. Please give the audience some insight into the history of our collaboration.
Yeah, I fully agree to what you said, and we started the collaboration with cellcentric in 2018, and we provided to a previous fuel cell system, the BZA100, the DC-DC converter, and this system was launched 2021 to the market and was used in commercial vehicles, but also in stationary applications. We have learned with this project a lot, and we could use that in the new program where we started the development around 18 months ago. And at the beginning, it was a very intense phase where both companies and both teams aligned together the product requirements and also the product specifications. And it was extremely helpful in this time frame that both teams are very experienced, are highly motivated, and that we also speak the same technical language. And with this, we have been able to create a product which is much, much more than just a DC-DC converter.
Yeah, that's true. The collaboration of the teams, including the management, was great. And that builds the foundation for our cooperation and the successful product development.
Yeah, we have now finished the B-sample development, so the products, the real products, are available, and we could already confirm the full power performance and also this very high efficiency. The products are currently tested in both companies, and the next important milestone will be that the system will be going to test campaigns of cellcentric's customers.
Yeah, we have seen that both companies have really benefited from this collaboration. So cellcentric receives a product that meets and even exceeds in some areas the specification, while Brusa, building on our shared expertise, develops a program that is at the moment unique in the market. And the close collaboration helped Brusa to better understand the key requirements and expectations in the heavy-duty transportation market.
Yeah, and this helped even if we are providing to fuel cells customers since more than 30 years, power electronics, so we are not new in this business. And there have been a lot of ups and downs during this very long time frame, but for us, fuel cells have been always an important business, important pillar of our whole business. And additionally, we are also convinced that fuel cells will play an important role in the future. For example, for these heavy-duty applications, this product is developed for.
Thank you very much for your time and for sharing your experience. At cellcentric, we are happy that we have signed the development contract with Brusa earlier this year, and several additional strategic partnerships with trusted companies in the supply chain will come in the near future, making now the ideal time to get involved.
Yeah, so we are also convinced that it's now the right time, as you said. So for me, it's now the time or the period in time when fuel cell technology will get industrialized, and we as Brusa, we are very happy to be cellcentric's partner on this journey. Herzlichen Dank. Ja.
Dr. Fink, thank you so much.
Thank you.
On behalf of the entire cellcentric team, and of course to remember today, take this as a token, with all the thanks to you and the team at Brusa. Thank you so much for the collaboration. I'm looking forward to walking that road with the fuel cell together with you.
Thank you very much.
Thank you so much.
Jochen, Dr. Fink, thank you very much for this great insight into a very strong and very long-lasting collaboration. Now, ladies and gentlemen, there is one vital puzzle piece missing in the comprehensive picture. And from the angle of the sales guy, that's not to be sniffed at, the customer. So, to look at the customer's perspective on our fuel cell technologies, we need to shift focus a little. We need to take a closer look at cellcentric's BZA 150 system, the predecessor to what we've been launching today, what is already out on the roads, accumulating miles on a daily basis. A product that's gone through hard and rigorous testing campaigns from north of the Arctic Circle to the south of Spain. A product that, together with our friends from Mercedes-Benz Trucks, is the current world record holder of the longest driving distance of a single tank of hydrogen fuel, 1,047 kilometers in a fully loaded 40-ton truck under real road driving conditions. And a product that is out in end customer hands as part of a field campaign. Now, to illustrate this, I have two special guests that will join me here on stage. First, I would like to welcome Ms. Kat Wunderle. Kat is with Air Products, and at Air Products, she is Sales Manager, Bulk Industrial Gases, Germany, and Kat and her team have been operating a Mercedes-Benz Gen H2 fuel cell truck with BZA 150 systems inside for a year. Kat, welcome to the stage.
Thank you.
And second, I have a very, very well-known person to the cellcentric family. I would like to welcome Mr. Lars Johansson, Senior Vice President Truck Technology at the Volvo Group, who together with his team is in charge of integrating our fuel cell technology into great Volvo products. And coincidentally, he's also the former COO of cellcentric and my former boss. Lars, welcome to the stage. Now, Kat and Lars, together with the two of you, I'd like to illustrate the two different dimensions that we have in mind at cellcentric when we say customer. On the one hand, looking in your direction, Lars, we have the OEMs, the organizations that are procuring cellcentric's fuel cell systems to integrate them in their own products and to pay us for it, which is also nice. But then we have the second dimension. We have the end customer, the truck operators, companies like Air Products, Kat, like you and your colleagues, who use these trucks on a daily business to keep their business running and to earn money with it, and who in the end will decide whether the OEMs did a good job with our products and whether our products performed well. So thank you very much for joining me on stage and shedding some light into these two perspectives, guys. Kat, starting with you. You operated that Gen H2 truck for a year as part of the regular fleet operations at Air Products. Looking back at that 12-month expertise, what are your findings?
Thank you. Absolutely we did. And importantly at Air Products, we didn't look at it as a demonstration project. We straight away wanted to put the truck into real day-to-day operations, and we did. We had it in Nordrhein-Westfalen. We were one of the first 5 trucks and had one truck for 1 year from November 24 to October 25. And we really pushed it to test the payload. So we're moving gases around. Gases, pretty light, but we're moving them around with heavy steel. So we had it in our cylinder gas operations based out of Hattingen on our production site, moving those gases around from home to depots or to the end customers. And it was a complete success. So the driver experience, very good. The drivers were queuing up. They really wanted to get trained on this thing. They really didn't want to give it back, and they were very protective about the truck once they had it. So the driver experience was absolutely brilliant. And the key thing for me, 2 months in, I went to the fleet operations manager and I said, it's been a bit quiet, how's it going? And he said, well, there, it's good. I haven't been to you because it's working, it's running, it's super reliable, and they were all amazed at how quickly they could integrate it into the day-to-day operations. It was good.
Great, thanks for these insights. Now, Lars, taking a step back in the value chain, looking at the OEM angle, you and your colleagues, you need to build a truck around those fuel cell systems. You need to integrate cellcentric's products in a very complex system of different components that need to interact with one another. What's your angle on that? How well does that work from an OEM point of view?
First of all, I would like to thank for being here, because it's very emotional to be here at this day where launching the NextGen. Fantastic. But speaking then from the voice of Volvo Group, and the integration so far, it's working, I would say, really well. First of all, I want to really underline the cooperation, I would say, how well that works, because when cellcentric was founded 5 years ago together with Daimler Trucks, it was, I would say, probably the first time where 2 main competitors went together to collaborate and cooperate about such a key technology, and that works really well, and also the work with cellcentric. But talking about the fuel cell, it's a heart of the fuel cell electric vehicles, but it's also a lot of other components around. And Nico mentioned something that is for us very important, is the cooling system and the heat reaction. So I think the integration works really well, and as you say, we're testing a lot. But I must say also, this is a proof of that the collaboration works really well, because we learn a lot during this phase now, the last years, to improve the system to really be a purely dedicated heavy-duty truck system. So really well.
Great, good to hear. And then it's not only about integration after all, right? Once that truck has been brought together, there's rigorous testing campaigns. That's daily business on an OEM agenda. A lot more rigid, lot more demanding operations than what a truck would see in a day-to-day operations at a company like Air Products, for example. Hundreds of thousands of testing kilometers under really adverse conditions for the technology. How do you see fuel cells performing in that domain?
Also surprisingly well, I would say. We're testing, as you mentioned, from Kiruna, north of Sweden, in Spain for hot conditions. And I must say it performs really well. I mean, in North Rhine-Westphalia, I know there is not so often minus 38, 40 degrees. But we have, sometimes people ask, why do you test your products so rigorously? because our customers use our products in this environment. I mean, we have a lot of customers in the north, I mean, in Canada, in Alaska, and also, of course, in the northern part of Europe. So this is nothing strange, and same thing, of course, in very hot condition. But I must say, again, coming back to the heat reaction and so on, I mean, that has been one big, I wouldn't say concern, but a worry with this, because and this is a huge improvement, I would say, with the NextGen that we can see. And I must also comment to what you said before, that it works and that you don't get complaint from your field service. That's a great sign. We love to not get phone calls from these guys.
If I maybe just piggyback on the testing as well, I was able to accompany one of the Gen H2 trucks on the mountain passes in Switzerland. And again, back to the driving experience, we overtook another truck going up the hill, up the Simplon Pass. Pretty cool driving experience.
Can't imagine the big smile on the driver's face.
You can imagine when you get the Volvo, then it's going to be even better.
Even better.
So you see there's a bit of rivalry in day-to-day operations at cellcentric after all. Now, Cat Air Products owns and operates a sizable fleet of trucks. Now, we're talking about one that you had integrated in your fleet. Looking ahead, as a truck operator, where do you see fuel cells fitting into your operations?
Yeah, of course, deeply embedded. And we just talked about it. When are the next ones coming as well? So we're just ready and waiting for the next ones to come. As I said, the fleet operations feedback was great. They said, when is the next one coming? We don't want to give it back. And it did integrate absolutely seamlessly. So we're ready. This is what we need next, right? We do need that TCO step change. We need to get that efficiencies. I talked about the fact that we're moving a lot of metal around with cylinder gases. So as I say, although we're moving very light products around, the transport actually needs to move really big payloads. So the TCO is critical for us. And during that year, we were really scraping the top of the fuel efficiency. Now we were really up at the top of the 8 kilos per 100 kilometers. So all of those step changes are exactly what we need. So this is a brilliant step forward, and we're looking forward to testing the next generation.
All right. Well, how did it work to make that happen? Now, from the point of view of a truck operator like Air Products, obviously a well-functioning truck, including a fuel cell system, is a vital ingredient in keeping your business running. So is the availability and the commercially viable price of hydrogen. And obviously Air Products is in the convenient position to also have a few of insights into that dimension. So from that angle, Kat, where do you see hydrogen availability and pricing for on-road transport and the other heavy-duty applications we saw today developing in the time to come?
So we're working on it. We're developing it. So importantly, as you said, hydrogen as a fuel for heavy-duty applications, it's proven now. It's demonstrated. It's not a question of technical feasibility. Now we just need to work on the economic viability. And we're working on that in terms of, the important thing for me is scalability. We heard that word a lot today, scale. And that's really what's going to make the infrastructure work. Now we need to work on the scalability of the production, the supply chain, the infrastructure, and the demand, the vehicles at the other end, and make sure that the end users are ready to take that next step. So Air Products, absolutely. We're working on the availability of the molecules. We've got significant improvements in the capacity, which we've announced in recent years. We've got the green hydrogen. A couple of weeks ago, we communicated that the new liquefier is solidly in build, 65% complete and on stream next year. So the molecules are there. We just need to get them in the right place at the right price. Different ways of doing that. But the real thing will be scalability. If we can get more vehicles to the end point of use, that price, we can get lower price if we can increase the utilization, bring scale, and again, the reduction in that fuel efficiency, or the improvement in fuel efficiency, the reduction in the fuel consumption, all that translates to a lower hurdle for the end users to cross. So I think we're on a good path.
Excellent. So we have the molecules in the pipeline. We have demand as a key enabler to further develop things in the right direction. So from a Volvo point of view, Lars, when will you have something in the pipeline Kat and her colleagues can try out and compare and contrast to the Gen H2 truck?
Yeah, so we are, as I said, we are very much in a very intense testing and verification phase right now, and we will start ramping up our pilot fleets now in the coming years, and really looking forward to put them in customer hands for real operations. Our focus will be Germany very much, Sweden as well, and it's very much for a practical reason. That's where we have the infrastructure coming and the customers that are ready to operate our vehicles, I would say. So we are getting there. We are a little bit behind our competitors from Daimler, but we are catching up, I would say.
Looking forward to it. Great. Now, we agree we're on a good pathway. There's quite a bit of work left, though, to really make it happen at scale. And admittedly, there are a few challenges left, so we won't be bored anytime soon. That much I think we can promise ourselves. So, from your perspective, what are now the important next steps that we need to take to really make it happen, to really get to the point where hydrogen and fuel cells are an integral part in heavy-duty, long-haul mobility? Kat, ladies first.
Well, for me, I think it's passion and confidence. Confidence that it works. We get that through these demonstrations, but passion. I think everyone here today is because they're passionate about this, and we're here because we want it to succeed. Now, you talked about this being your baby. Now, for me, the hydrogen fueling and the hydrogen fuelers, having a truck in our operation with our liquid hydrogen through a hydrogen fueler that we've put in place in Duisburg, that was my baby moment. And I think that passion will help us all put the pieces of the puzzle together in a way that will really drive this forward. Confidence, we'll make it work. The molecules are there, the trucks are there, the technology is coming. I'm confident in the future.
Thanks for sharing. Lars, your angle?
Yeah, so first of all, it's my boss always reminds me of that about dig where you stand. So I mean, first of all, it's about us delivering total cost of ownership competitive vehicles, and I'm very much convinced that we are on the right path with the vehicles. Even the first vehicles we're putting out performs really well, good driving range, faster fueling times, good efficiency level, and with the next generation. And also the next generation vehicles, we will take a big step in that direction. So I would say competitive vehicles and fuel cell systems, that's definitely number one. And then when you were into that, infrastructure is a key here, I would say. Of course, with great trucks, but nowhere to fuel, it will not work anyway. So infrastructure. And then I would say connected to that also a low and stable, I would say, price of hydrogen. Because there we have some experience from other parts of the world where, for example, in California, there was a very big hype, and then the price of hydrogen rise so high, so the end customer doesn't see it viable to use. Because end customers like you running on profits, I mean, you need to have a profitable business, and if the cost of hydrogen is too high, you will stop the vehicles, basically. So that's the third one. And the fourth one we were on to before is the policies and the regulatory requirements around, I would say, is also a key here, I would say, to help driving this transformation. And I see really good progress, not at least in Germany now, where things are really starting to happen. So that's a lot of good signs there, I would say. So and all this needs to play together, I would say. Then we will be successful, and I'm 100% sure that and confident that we will be successful going forward. But it has to play together.
All right. Kat, Lars, thanks a lot for these candid insights, the voice of the customer of today's event. Thanks a lot for contributing. Thanks a lot for speaking to us. Ladies and gentlemen, give a hand to Kat and Lars. Now, ladies and gentlemen, we've achieved our target of the afternoon. BCA 375 is out in the open. And my team and I were looking forward to presenting it here to the public at Hannover Messe all week, and at many shows to come over the course of the year, because, as you can probably tell by now, we're a bit proud of it, and we want to show it to the world. We have proven technology in fuel cells for heavy-duty trucking. We have established fuel cells provide fitness for purpose and competitive total cost of ownership, the two key criteria to be competitive in the heavy-duty space. We have seen the high degree of technical innovation and significant performance boosts that lie behind BCA 375. We've seen the momentum that is being built in the hydrogen ecosystem, and we've seen the strong collaboration we have both with our strategic partners from the supply chain on the one end, and with our customers and their customers on the other hand, to bring it all together. Ladies and gentlemen, I think there's never been a point in the past where preconditions to make hydrogen fuel cells in the heavy-duty space happen have been as promising as now. let's jointly roll up our sleeves and get the rest of the work done. From a cell-centric point of view, we're fully committed to that target. Allow me to say a thank you to all the speakers who contributed to our presentation today, gave you the insights of all the different dimensions, and as much as we try to give you a comprehensive overview, I'm totally confident there are a few questions left. And therefore, we very deliberately have that networking session into which we will now gradually migrate. And please use that opportunity, ladies and gentlemen, to openly approach my fellow speakers and myself with all these remaining questions. And not only approach them, we also have many more cell-centric colleagues here joining us today that are also available as representatives and as sparring partners for you. We made life a bit easier for you because we all clothed them in these nice shirts, so they are easy for you guys to identify. Use the opportunity, engage, discuss, create, and jointly start to drive hydrogen forward tonight. From my end, ladies and gentlemen, there is one very important thing to say. We now migrate to snacks and drinks, which is probably also something you've all been waiting for. And I'm very happy that you joined us today for this event. Ladies and gentlemen, NextGen starts now. Ladies and gentlemen, thank you very much for your attention. Enjoy the evening. Thank you.